Hi, welcome to today's webinar, Specifying Sustainable Outcomes. So today's webinar is going to last about 55 minutes, maybe 60 minutes. Everyone attending is muted, but please ask as many questions, put as many observations in the chat, which pops up with the sort of question box on your screen. And we'll try and follow up as many of those as possible after the session. Today's webinar is in association with Vectorworks, who's sponsoring this webinar. We have a little bit later on in the webinar from Vectorworks themselves, a little video sequence. But the first speaker is from BCIS. BCIS are our partners on the early stage spec library. And we're going to hear from James Fiske, who's Chief Exec of BCIS and Chair of the Built Environment Carbon Database Project. Middle part of the webinar is going to be from myself. And then we'll finish with a couple of video sequences showing how the specification links with 3D model from early stage onwards. But yeah, just to pass straight across to James Fiske from BCIS. Over to you, James.
Thank you, Stephen. Absolutely delighted to be with you today, and thank you in advance for inviting a quantity surveyor into the hallowed walls of NBS. Yeah, my name is James Fiske. I'm the Chief Executive Officer of BCIS. I'll talk to you briefly about BCIS shortly, but I also chair a pan-industry initiative called the Built Environment Carbon Database. As I say, absolutely delighted to be with you here today. Just a very brief slide on the Building Cost Information Service. BCIS has been around in the industry for a good 65 years, providing predominantly construction cost and price information over to the construction industry. So it's a tool that's used by quantity surveyors and building surveyors in the main in order to provide information for various sort of activities that they'll be doing over the life of the construction projects that they're working on. So I've got a very brief graphic that explains this. So during the life of a construction project, the project will go through a number of different stages. So an appraisal stage, a design stage, a construction stage, and then you operate after you've finished building it. You operate that asset or building for hopefully many years, and then it comes to the end of the life. So broadly speaking, they're kind of the stages that a construction project would go through. Obviously, there's a lot more detail behind that in terms of the REBA plan of works that you'll all be familiar with, but this is just a high-level graphic to explain what BCIS does. So in terms of costing projects, information at the very early stage is limited. You know, we don't quite know the full specification of a construction project at the appraisal stage. We're more likely to know that it's a type of building and perhaps a size in a particular location. So BCIS provides data to facilitate that appraisal stage of a construction project by cost per meter squared or functional unit information. So the typical price of a warehouse or a factory. That's the type of data that BCIS provides. As we get into the more sort of conceptual design stage through to detailed design stage, we start to understand a bit more information about what's involved in the makeup and the build-up of those construction projects. And again, BCIS has been designed to provide information progressively, more and more granular information. So initially, it will be cost of typical elements and systems, and then getting more detailed in terms of components, approximate quants, and then finally, when we're at the sort of the detailed design stage, very detailed costs for activity rates, including labor, materials, and plant. And we'll be talking briefly about this in context of sort of sustainability data a little bit later on in the webinar. It's only once a project has been through the construction phase that obviously we understand the full makeup of all of the components and the materials that have gone into it. And likewise, after we've actually run that building for a number of years, it's only then that we truly understand all of the maintenance and replacements and all of those in-use activities to keep the building sort of going over its life. So really, in a nutshell, BCIS is designed to supply information to either improve estimating accuracy or to facilitate benchmarking, to make sure that you can demonstrate that, the design team can demonstrate that you're getting value for money with the construction projects and the specifications that you're making. So just a brief slide on BCIS there. What I'm really here to talk about today is around climate change, and what is undoubtedly the greatest battle and the greatest challenge of our time that we're currently going through at the moment. I'm not going to jump straight into a rant about this, but we're just going to focus on one key measure, which around 40% of global greenhouse gas emissions come from the built environment. That's not just the construction, but obviously the operation of those assets as well. If those are left unchecked, i.e. we don't do anything about it, they're predicted to double by 2050, which is incredibly scary. So I'm presenting today from Norfolk, and walking around Norfolk at the moment, there's quite a bit of floods going on. Walking around almost in my waders here in Norfolk. It's the effects of climate change are happening now. We are witnessing this, and unfortunately, it's our sector that's predominantly responsible and for those greenhouse gas emissions that are being generated, and we need to do something about it. So, as a construction professional, it's our duty to the planet to reduce those impacts. Everybody, every single construction professional, everyone joining this webinar today has a duty, an ethical duty to the planet and its inhabitants to do something about it. The scary statement is that, you know, in the future we can't reverse the decisions that we're making today. We have one opportunity of getting in and reducing the emissions caused by the activities that we do. So we need to make sure we're making the right decisions, and that's really what this webinar is about today, making sure that we're armed with the correct data, information, knowledge to be able to drive down the effects of what we're doing from construction projects. So historically, as a quantity surveyor that I am, we would be talking about the time cost quality triangle, which I've drawn as a Venn diagram, because those things are inextricably linked. You can't impact time without having some kind of impact on either quality or cost. And likewise, if you need to reduce the cost, undoubtedly it will have an impact in terms of time and quality. So this is a well-known concept, and obviously with construction projects, we're trying to juggle those three things and try, if we can, to get in the middle of that of the interlocking time, cost, quality there to find the optimum sweet spot for our construction projects. Times are changing, you know, as we talked about in the previous slide. We need to start quantifying and reducing the carbon emissions of our construction activities, and we're now at the stage where our time, cost, quality triangle has now become a square. Again, an interlocking Venn diagram of 4 parts there. So as well as time, cost, and quality, we also now have carbon or environmental factors. So again, carbon and the environment inextricably linked to those other things. If you adjust and need to reduce your environmental impacts, undoubtedly it will have an impact in terms of things like cost. There may be impacts in terms of quality and time, depending on some of those sort of solutions that we go for that are lower carbon. So we're now at a space where we're trying to measure and manage 4 main aspects of our construction projects. One of the common questions that I get asked on a very regular basis is, how much does it cost us to decarbonize, to go for lower carbon solutions and specification options? So we're now at the stage where the design team needs to be prepared, needs to be thinking about those impacts, and needs to be able to sort of answer those questions. So in order to balance those time, cost, quality, and carbon together we need to try and simplify the process. The easier this process becomes, the more likely that more people within the industry will do it, and the greater influence we'll be able to have on decarbonising the built environment. So there's a measurement process that goes on construction projects undertaken by quantity surveyors. So they are measuring in order to price and understand the cost of things. We should be looking to use that measurement process in order to quantify carbon. If we can do cost and carbon at the same time, it becomes much easier to sort of explain, the impacts of cost on lower carbon design solutions. So a lot of the data and the tools that BCIS are producing at the moment are focused on trying to support quantity surveyors in particular to understand the cost and carbon values. But also we're fully aware that everybody in the design team needs to do their part in order to reduce those emissions. The earlier on in the construction project, the greater chance we have at reducing the carbon values, the carbon impacts, if you like, of what we're trying to do. So we do need the whole design team to understand what the impacts are. So a common level of understanding, and also data across the whole design team to facilitate those conversations is the only way that we're going to be able to impact and reduce our carbon emissions on construction projects. So in order to drive down our carbon impacts, we need to avoid the garbage in, garbage out scenario that unfortunately happens quite a lot at the moment when it comes down to carbon accounting. So if you ask 5 different carbon accountants to measure the carbon impact of the same building, chances are you're going to get 5 different answers out at the moment. And a lot of that's driven by methodology, but the main driver is all about data. We don't have a rich history of carbon data to draw upon, and that means that people are pulling whatever data that they possibly can, right or wrong, in order to try and do their best to decarbonize. And we need to improve all of that if we're going to get to this place where we are having the proper, correct impacts to reduce our carbon emissions. So BCIS has been very conscious of this data availability issue, and about 3-4 years ago pulled together a number of industry bodies to try and do something about it. This isn't a particular problem for a single construction discipline such as a surveyor. This is a problem that the whole industry has, and we need to do something about it. So BCIS has pulled those sort of professional bodies, the logos you can see on the screen, together with a single mission of trying to increase and improve the availability of carbon data in the built environment. The built environment carbon database is not a calculator, it's not a piece of software, it is purely an online data repository. So anybody who's looking for carbon information can go freely onto the built environment carbon database and hopefully find and access the information that they need in order to facilitate and drive down the carbon impacts of whatever role that they're fulfilling in the construction industry. The built environment carbon database is actually 2 databases. One is at project level data. So if you want to understand the typical carbon emissions of a warehouse or elements of the warehouse, you can go into the built environment carbon database asset section and sort of look up that information. The other database is much more granular. It's material and product level emissions. And with this particular database, we're capturing environmental product declarations, EPDs, and other LCA measures increasingly over time into a single sort of database that will hopefully make it much easier for people to measure, report, and reduce their emissions. We're at step 1 of what will be, unfortunately, a bit of a longer journey. Step 1 is about pulling all of the data that's available into a single place. Step 2 is looking at that data, understanding where the gaps are, and also trying to do something about the consistency of that data. EPDs in particular are very inconsistent in terms of how they're measured. So the EPD for paint, for example, one EPD could be per meter squared coverage. One might be reporting the carbon impacts per 5 litre tin. One might be reporting per 20 litre tub. You know, there is major inconsistencies in terms of the units of measure, but also within EPDs, there's some different assumptions that are being made in terms of how long things last, what the maintenance and replacement type activities on that product are. So we're at step one, really, of pulling that data together, understanding where the gaps are, and then trying to come up with a plan on how we can improve the consistency of that data sort of going forwards. BCIS are taking the data from BECD and linking that over to our cost data with that view that we're obviously trying to combine the measurement activities so that we can report cost and carbon in the industry at the same time. So what we see in front of you is the first part of that. So we've used outputs from the Built Environment Carbon Database for materials and products, and we've linked that over to the BCIS cost libraries that we've been capturing over the last sort of 65 years of different materials, and we've developed a database which is a materials cost and carbon database. So the idea being that you can understand the cost, you can understand the inflation, past and forecast inflation, and other bits of information that could be useful in terms of sort of specifying and selecting sort of options for materials. That data rolls up into a component lifecycle costing database. So we have a big library of building components, if you like, Lego blocks of your construction project, that for each component we have a series of data points on it. So if we take the example ceramic floor tiling, as we have, there's a number of activities that happen on that ceramic floor tile over the life of the construction project. The first activity is obviously to put it down and install it for the first time. But then there's maintenance activities that happen every X number of years, and replacement activities when the tile needs to be picked up, stripped out, disposed of, and put a new floor finish put back down again. So within our component database, we have all of the activities modeled for what happens over a component over its life, and then each of those activities is built up from labor, materials and plant data. So the materials database is one of those bits, but there's also labor. So they're all quantified activities that roll up into eventually into our components library. That data feeds into two things. So absolutely delighted that we've been able to provide that data into NBS Chorus that we'll be talking about shortly. This lifecycle costing component library that is provided in Chorus has been developed in a way to facilitate discussions between the design teams. So within NBS Chorus, they're indicative values, and to try and make them real rather than just have 1 meter squared or one number or one linear meter of each things. We've developed a generic model of a 3-story new build office building, which and the idea is that the quantities that you're seeing on NBS Chorus are applicable to that type of building. The idea is that you should be able to look at those components, and it's a relatively high level data, but it shows you the cost, the ongoing maintenance and replacement activities, and the total in terms of cost. And then it also provides the same information when it comes down to embodied carbon. So what is the construction carbon? What's the ongoing maintenance and replacements that are needed on that component over its typical life? And again, what's the total carbon emissions? So within Chorus, you'll be able to search, sort, and filter. So if initial cost is the main driver, you can search by that. But obviously, what we'd like is a holistic people to be using it for a holistic economic view to understand what the typical trade-offs of cost and carbon numbers are. There's also a column of data there relating to life expectancy, so how long that particular component is likely to last. And that data comes from a BCIS survey, which we undertake on a regular basis. So this isn't the manufacturer claiming that the product lasts a certain amount of time. This is actually based on real data and feedback from the industry. So that data is delighted to say is now available on NBS Chorus. So hopefully this will start to arm designers and specifiers with information at the earlier stage, so that we can have a real impact in terms of reducing our carbon emissions. That data also feeds into the BCIS lifecycle evaluator, which is a tool that BCIS subscribers have access to, which gives them the ability to do whole life carbon assessments and full life cycle costing reports. So we've kept things like the BCIS code in the NBS Chorus product, so that as a design team, you can start to identify a particular number here. And then whoever's doing the cost and carbon sort of quantification, they will be able to pick up the BCIS lifecycle evaluator and start to, adjust to those costs and carbon values to suit the specific details of the construction project that they're working on. So again, this is all about trying to arm the design team with a common set of knowledge and definitions, so that those discussions can happen, and ultimately we drive down carbon emissions. So with regard to the data that pumps into NBS Chorus, they are indicative values, and they are designed to facilitate conversations in the way that I've spoken about. The numbers will vary dramatically based on all sorts of things. So obviously we've provided data within NBS based on a generic office building in a particular location with a particular set of sort of specifications, really. They will change quite rapidly if you start to specify tiles from Italy or something like that. The carbon numbers will obviously change quite significantly. The other thing that will have a massive impact is obviously how long you run your analysis for. So we've picked an industry sort of standard 60 years on the data that's provided within Chorus. Now that will also change the whole life cost and carbon numbers depending on how many years you actually want to run and operate your building for. And the final note is that you can't add up the numbers and expect to come up with a compliant carbon assessment. If anybody's seen the carbon assessment standard sort of methodology from RICS, it's quite a complex sort of 200-page plus document with lots of things that you need to consider. So again, the idea of this data is to facilitate discussions and collectively to drive down carbon emissions. Stephen, if I can hand back to you, hopefully that made some sense.
Yeah, so thank you very much for that presentation. James, just a few questions before we go on to the next part of the webinar, but where do you think the drive for whole life cycle carbon analysis is coming from? Is it private clients or government, local authority? Where do you see this drive coming from?
That's brilliant, a brilliant question, a good challenging question to start off with, Stephen. Thank you very much. Yeah, there isn't a mandate from government to do a whole life carbon assessment as yet. We know it's coming down the line. There's a number of industry initiatives such as Parts Edge, which is kind of linking carbon assessment into future building regulations. So that this is actions that are coming downstream from the government, and they're going to be in place pretty soon. But what we have seen is a number of drivers that are in place already. Some planning departments require whole life carbon assessments to be undertaken as part of the planning process, which is great, and that number is growing. So we are seeing more and more examples of those assessments coming through the planning process. What we're also seeing is that some organisations, certainly of a particular size, have to report their ESG credentials. So Scope 1, Scope 2 and Scope 3 emissions, certainly Scope 1 and Scope 2 are covered, but Scope 3 is a bit optional at the moment. But so if you're a contractor building something, you will have to be measuring aspects of this if you're on site running diesel plant, and you know that's all of the types of ESG reporting that has to be undertaken. The other thing that we're really realizing and seeing a bit more of in the industry is that a building with green credentials seems to command a greater value. There's a lot more interest in it, not just from a PR perspective, but if you've got a green building that is going to be operationally efficient, then it's going to save you money sort of running and operating that thing over its life. So we're also seeing a direct correlation now between sort of the value of buildings and how attractive they are to end users and tenants. So there's a number of sort of drivers that are happening in the absence of that sort of main government mandate, Stephen.
And in terms of the ESG reporting, is that a requirement for the client that's like funding the development of the building, or the main contractor that's actually building the building, sort of thing?
It could be both of them, of course.
Okay.
So yeah, depending on the size of the organisation, I can't remember exactly what the size sort of legal reporting parameters are. But if you're of a certain size, you have to report your Scope 1 and Scope 2 emissions. So if you think of Scope 1 and Scope 2 really being, you know, the energy and the fuels that you are directly burning yourself. So it's going to be more applicable to the likes of contractors who will be on site, you know, as I said earlier, with the construction plant and that type of, you know, energy use for site huts and everything else. That will all have to be measured as part of the Scope 2 emissions.
And I guess the term whole life cycle means embodied carbon's important, but it's not the only metric. So I know I speak to manufacturers like clay brick or cellular glass insulation, and they've got high embodied energy, but they could last for decades and decades.
That's it. We had a bit of an industry drive recently, just focusing on operational carbon, but unfortunately, what we failed to consider was any emissions responsible for creating something that may have a lower operational sort of carbon footprint in the future. So it's really important to consider not just your upfront, but the whole life. So that includes your your initial construction. That needs to include all of the maintenance and replacement activities, and it also needs to include all of the operational carbon that particularly in the likes of M&E components. Those things can have quite a significant footprint themselves. So we have to appraise on all of those things, because if not, the danger is that we could be making the wrong specification choices, i.e. we go for something because it's lower upfront, but actually over the life, because you're replacing it every 5 years, could end up meaning that what you've picked over the life of the building is probably the worst specification option you could have picked. And likewise with the example that you used, there might be a higher embodied carbon number up front, but because they're more durable and you don't have to replace and maintain them as much, the number over the life could be significantly lower than other options. So yeah, it's really important that you consider all operations, all activities over the life.
And what you were saying about environmental product declarations, normalizations, if you had a concrete slab, you might have one manufacturer that's measuring it in meters cubed, one in per unit, 1 per meter squared. I guess there's some sort of A-level maths with volume density and declared, and you sort of try and standardize that between different manufacturers, I guess.
Yeah, I mean, it is a challenge, and it is a real barrier to being able to compare one product with another product in the way that we're sort of talking about needing to do there. So yeah, the maths behind the conversion, all EPDs will report by weight. So if you understand the weight of something, you can use weight as a proxy sort of calculator. In terms of BCIS, we've taken all of the data from BECD by linking it over to our construction cost data, we've had to convert it so that it's in the same units of measure as how we would price and measure to price things. And yeah, that can be taking meter cubed value over to a linear meter of skirting board, for example. So some of the maths can be quite complicated in terms of working out, well, how many bits of skirting board can I get out of a meter cubed of timber, for example. It has been quite a head scratching moments at the BCIS camp, Stephen. But we've got there.
And I guess if we rewind back up that project timeline, the EPD and manufacturer information is when you're starting to almost get to the technical design stage, but the big decisions that can make sort of big percentage points worth of movement is early stage, I guess, where you're making the fundamental decisions.
Absolutely is. You do. I mean, you pick the normal concrete frame versus steel frame at concept design stage sort of discussion. You know, pitched roof versus flat roof. That's the time in a construction project where you can make a real difference. So I think I mentioned it in the slides earlier. The earlier on the timeline of a construction project, the greater influence you can have in terms of reducing your emissions. The longer you leave it, so if you're right at the detailed design stage, you're very limited in terms of, you know, actually you can pick 5 or 6 different construction products that will sort of suit that specification, but you know, you're not able to swing it as much as you would do earlier on. So getting in there early is really important, which is why we need the whole of the industry sort of, you know, trying to measure and understand the carbon impacts, because yeah, concept design stage, big chance to reduce emissions. Absolutely.
And I deliberately asked that question because it takes me into the next question. And whilst you're still on the webinar, before I sort of show the NBS BCIS sort of joint initiative off, I thought I'd put it on the screen and ask to get you to explain it a little bit. But what we've got on the screen here is the library. This is the Uniclass library, and it's sort of high level things like walls and roofs and floors and stairs and things. But if I go to like roofs, you can see we got there at the level of like arch roof, curved roof, or just roofs in general. And on this roofs page, which I've sort of got open, you can see the link that jumps across. There's 15 different priced items in terms of either carbon or cost for roof coverings. And I'm just going to put a big version up of what you had in your slide.
That's good.
So I think we'll start at the top and work down, but there's some assumptions here at the top that these bar charts are based on. Do you want to just maybe talk us through the assumptions again?
Yeah, absolutely. So rather than try and present some information which would be 1 meter squared of lots of different options, what we've done with yourselves, Stephen, here to try and make it a bit more meaningful is to create a generic model, an archetype type model. So the values that you see on screen are applicable quantities, which you can see in the top left. Yep, quantity of 900 meters squared, which is the typical quantity for our 3-story new build office building that it sort of tells you in the top right. So it gives some context in terms of, you know, the typical sort of areas. Yep, you just highlighted 2,000 meters squared, which is our gross internal floor area, designed for 300 people, 75 cars, based on a UK mean location, brownfield site, but with good access and working space. So we've got indicative quantities and therefore values that come out from the BCIS database that I sort of ran through earlier for that type of building. The lifespan is 50 years as opposed to 60, which I said I think in my slides earlier, Stephen. So changing the lifespan will obviously ultimately change these numbers. And the location is UK mean, which doesn't have a huge difference in terms of obviously carbon numbers, but the costs significantly change regionally, of course. So yeah, they're designed to be indicative values to help those discussions. So you can, you know, through this system, you'll be able to you know, what's what's predominantly one of the main drivers for our client. Well, they want a low carbon building. You know, they're interested in obviously the whole life carbon numbers for the reasons that we talked about. So within this system, you can do a sort of that data to get to. There we go. That's beautifully demonstrated by you there, Stephen. So you can sort on the things that are most important, whether it's cost, whole life cost, ongoing maintenance, or totals of those things. And the idea is that can then facilitate a discussion. So BCIS code 2.3.4.1. When you're sitting around the design team, you can, you know, as a designer or a specifier, you can turn around and say, well, you know, based on what we know is important to the client, we think that something like the plastic coated galvanized profile sheet cladding would probably be a sensible one for us to pick. And then because you've then got a common set of data and a common language that you can now share with quantity surveyors and carbon accountants, they can then pick up and go, yeah, well, actually in this case it's going to be a slightly larger volume. It's not 900 meters squared. It's double that. The lifespan we need to analyze is actually going to be 80 years. And they can then start to use the tools and the BCIS data in a more granular way to refine those cost and carbon impacts that we can see on the screen.
And if we just look at this one, 234.5, because I hope you're going to say yes, that's right, Stephen. But we've got a lifespan of 50 years, and that's 33 for the initial 33,000 there for the initial construction. But because the life expectancy is 30 years, you'll be having to fully replace that roof within that 50-year period. So that's why you've almost got double.
That's exactly right, Stephen.
Yeah.
Absolutely right. So you can also then imagine that if you moved your analysis period up to 70 years, you'd see that replacement happening twice. So, so again, quite a big difference in terms of what would be your whole life carbon number based on that lifespan sort of analysis period. Reference service period as the carbon accountants, you know, in terms of the carbon standard, refer to it as.
Whereas for the financial cost, that's not double, because every year there'll be yearly maintenance where people are getting up on the roof and maybe replacing a few components and cleaning it for leaves and things like that.
Absolutely right. Yeah, absolutely right. Yeah, so there's a number of factors in terms of what needs to be completely replaced. There'll also be an element of in the life cycle costing world is the what we call net present value, which is a way of discounting future costs. So again, the quantity surveyor will understand that number and how it's been built up from the more detailed information that's available in the BCIS system.
And then a lot of the assumptions are sort of laid out there, down to occasionally where it's actually, like, this is based on a particular manufacturer's products, but it could go up or down depending on which manufacturer's solution is ultimately chosen.
I mean, we want to be moving into the space with yourselves where, you know, traditionally, unbelievably to say, there hasn't been a great deal of alignment between design specifiers and costing. You know, everything from classifications and the way we do things have been completely different. What we want to get to a place with yourselves, Stephen, is that you can build up assemblies using the BCIS data. So as users of Chorus are going through and specifying that actually I want this insulation, I want this particular board, then we should be able to find a better alignment between what we're doing from a cost and a carbon perspective, sort of going forwards. I
guess for those interested in classification, whether it's common arrangement of work sections or uniclass, we're doing the work between ourselves to map sort of what it's many to many actually relationships between uniclass there and the BCIS codes at an early stage level. But I also noticed with your materials database you have uniclass product clauses in.
That's correct.
Sorry, classifications in as well.
Yeah, that's absolutely correct. Yeah.
Excellent. Okay, well, I think that brings us to the sort of end of the first presentation from yourself, and it sets things up nicely now where I'll actually show where this information sits in the specification process. So thank you very much for your time today, James. Thank you.
Thank you, Stephen.
Okay, so we've just heard from James about the BCIS, their approach to sustainability and the data that sort of defines sustainability. And we've had a little look at the content from BCIS that we're displaying within the NBS Early-Stage Spec Library. So we just take a step backwards now, just 10 minutes from myself looking at this sort of new content add-on. So yeah, Early-Stage Specification from NBS. And what we're wanting to do essentially is you've got the traditional place in a project where NBS is used to write that sort of technical specification that sort of defines the quality prior to construction. You may specify things like masonry leaf or a modular ceiling. And what we're trying to do with the early stage specification is allow that specification process to start much earlier in the project. So before you know whether there's going to be masonry leaves or modular ceilings, specify the overall requirements, capture the client brief at that sort of really sort of concept design stage. So produce a sort of, as RIB, a plan of work terminology, is at the end of concept design, have a tight outline specification that can then develop into the technical spec. So not a masonry leaf, but a wall in terms of its fire, thermal, sustainability, technical characteristics. So that's the sort of concept. And that will give the benefits of a better document and capture the client's brief and sort of shape things up nicely for conversations with the planning authority. To give that sort of fixed, I guess it's an overused term, the golden thread, but at the start of the golden thread, to have those fixed performance requirements for each element in the building, walls, floors, roofs, etc. And to allow for communication and collaboration. So client with architect with building services, structure, cost consultants, because at this early stage is where the biggest influence on those decisions can be made. And that's the ideal route, that outline specification as defined in the RIBA Plan of Work 2020, is that ideal route into the technical specification development. And that's, as I mentioned, that's that fixed set of requirements that you can verify the final decisions against and assess change requests as they undoubtedly come on a project. So imagine a sort of concept design here. It's our NBS restaurant model that we use quite often. You've sort of understood the client requirements, done the basic sort of concept design, and you're sort of thinking about what activities will happen in the building, what spaces are needed to support those activities of things like cooking and eating and washrooms, etc. And then for the right environment in each space, you're going to be breaking down that building in terms of its major elements before you make any sort of real detailed technical decisions. So we can see around the sort of building envelope here, we've got different types of elements, external wall, 1, 2, 3, etc. And you have an idea that some maybe sort of more sort of glazed wall and others will be sort of solid walls made up of different systems, etc. But no sort of absolutely solid decisions yet made. So if we look at the sort of principles behind this, is you've got an element that could be made of many things. The things that are fixed are the performance requirements. You might have a budget, almost certainly in terms of cost and increasingly in terms of carbon. But there's still lots of different ways those performance requirements could be met. So with masonry frame or steel frame or timber frame, etc., of different width and strength and performance. In addition to thinking of the technical performance, working with BCIS, you can get an indication of what those financial costs are, what the embodied carbon costs are, plus also the operational costs as well. So you can make those decisions with your eyes open. You can have those conversations with the cost consultant, understanding that one's going to be twice as expensive as the other, or 60% larger in terms of embodied carbon. So let's just look how a specification would develop for something like a wall using Uniclass for this example, but it could quite easily be the section that we've got for common arrangement work sections, which is B60. The principles are the same. Software functionality is slightly better for Uniclass because you can have the link and the sort of cascade of items from element to system to product. But in NBS, at a very early stage, you might just capture the sort of functional requirements, the brief for a particular wall. So think of that concept design earlier, the external wall to the back of house. You said this is going to be type 10, and you're just sort of capturing some of those initial decisions. Next stage as you move through the project is to say that these are the functional requirements, and they will be met by providing a wall of the following fixed elemental performance in terms of things like U values, fire performance, durability performance, water penetration, what have you. And just like all good NBS principles, specifying a technical value with the correct units and citing the right standard. And then in conversation with the cost consultants, maybe referencing the BCIS code, you could put some of the assumptions that you think are going to be in there in terms of cost and carbon that helps work towards budget. And then the project progresses further, and this is where the performance can be provided by a number of systems that come together. So something like rain screen or masonry leaf with internal wall tile in the middle. And these decisions can always be cross-checked back to that fixed performance. In an NBS Chorus, you can add those in as placeholders. And then as the project progresses into that technical design stage, replace those placeholders. So you see they go from the gray placeholder links, the gray color here, into the colored solid links. And that's where you're getting into your traditional NBS, where you're specifying either work sections and cores or systems and products using uniclass. And you can see in the uniclass content, it maintains the boot marks from wall to system and back upwards again, all the way down to the products that the system is built up front. So a particular cladding system being made up of the following: carrier rails, insulation, particle boards, etc. So the scope of content, which is all live now on the building fabric side, is things like walls, floors, roofs, openings. Also, there's services like the function of drainage, ventilation, heating, external works, decking, pavement, gates, and also the key structural items as well, like foundations, frames, retaining walls, etc. On screen here is the basic clause template, and you can cross out and park all of the items that you don't need, but they're there as prompts with synchronized guidance on the right-hand side. And as the project progresses, you can start at the top and just sort of work down the clause as you do with any other clause in NBS. And that structure is pretty much identical, whether this is a B60 classification reference or an EF for uniclass elements in function. I think this actually is the common arrangement of work section example here in terms of terminology is talking about work sections. We've talked in depth about the BCIS guidance, and that comes off the link on the right-hand side and shows you that comparator table. And you can open as many of these windows as you wish. So if you wanted to compare timber cladding with rain screen cladding, you can have two windows open at the same time. So a little bit of a summary, and then I'll show you where you can find more information about this, but better capture the brief, fix those performance requirements at the elemental level, improves collaboration, understanding across the whole team. Key, a service that's offered by from the lead designer, working collaboratively with the other designers, clients, cost consultants. And it's a great route into the technical spec for when developing the technical spec and cross-checking any verification or substitution decisions later on in the project. So in terms of finding out more information about Early-Stage Specification Library, we're going to send this link out afterwards to everyone that's attended the webinar, but it's a sort of long read version of the presentation that's I've just presented. So I went through a little bit too fast. I know I sometimes do. We try and get it all into the hour. You can have a sort of slow read here. And we got a really, well, I thought it was a fantastic interview with one of our technical authors, Gordon Gray, who was the lead author behind this initiative. So if you want more information about the early stage specification, please check out this interview with Gordon. So the final part of our webinar is a couple of video sequences from our sponsor, Vectorworks and MScheck company, where we're looking at how the specification integrates with 3D model in the Vectorworks environment. So yeah, so very big thanks to Vectorworks, our webinar sponsor. And we're just going to look at this example provided by the guys at Vectorworks, just showing how you can use Chorus at that early stage. We've got concept design on the screen just to start linking up the sort of key elements of the building. So you're seeing associations being made to the window type in the 3D model there with the specification from NBS. So it's scanning the whole model, finding all instances of a particular door type and associating that with the door element that's in your sort of outline spec. So we've done windows, we've done doors, and what we're doing now is just linking that entire wall element to the external walls element clause in NBS. And you can have the NBS window open. It's exactly the same content. You log on the same in that design environment. So you've got the concept design in Vectorworks, and you've got all that fantastic information from NBS BCIS at the fingertips of the designer. So you can capture the brief, you can put the performance requirements in, you can look at the sort of BCIS data there and put some of your assumptions in against that particular wall based on sort of where you think it's at in terms of those early decisions, or what are the sort of fundamental materials. And then jumping forward, you now see the model's no longer just that sort of white model from the concept design, but it's developed up in a sort of full technical design. The specification and parallels now looking at systems and products. We're getting down to masonry wall leaves. You've got gypsum plasterboard, clay bricks, aggregate blocks, and the links can be made at that material level. So just create a little link here between the damp-proof course in the model with the damp-proof course in the specification. Next one we do, there's clay bricks, just looking at the material layer in Vectorworks, linking that to the clause in NBS, doing the same there with the concrete blocks as well. So you early stage, you're doing the links between that sort of large chunky element and the elemental clause. But now at the technical design stage, we're down to the level of things like insulation, clay bricks, concrete blocks. And that little model report in NBS is querying that Vectorworks database to show all of the objects that are either unassociated yet or associated in that 3D model. The little purple chips there showing what has been linked. If we look at something like mineral wool insulation, what we're going to do is make the specification choices here in the NBS plugin for Vectorworks. Now quickly filter to show the insulation from the manufacturer Knauf, and I've clicked the button add to spec, and we've got all the technical properties from the Knauf insulation dry firm cavity slab being dropped into the specification. And if we jump across to the wider screen on NBS source, you can see you get an extended amount of technical information. Just scanning down the page here, there's a guidance on suitability, third-party certification, same technical characteristics there. We have this little sustainability data card further down the page, and you can see that the EPD for Knauf insulation here has 1.13 kilograms of equivalent carbon per kilogram. So we're going to jump to that same material now in Vectorworks. Fortunately, this is the same units. This is per kilogram. You can see on the screen here. If it's not, like based on what James was saying earlier, you'd have a bit of maths to do. If that was per meter squared, you'd work out the density. But that's been put in like for like units. And you've just seen here how you can use some of the great information we have in NBS in other tools. So we're going to the sort of embodied carbon calculator in Vectorworks. Going to the particular material name here, mineral wool insulation. And as that's put in, you see row 10.1 there's been populated in terms of quantities and the values there. So two great tools coming together. Got the modeling tool from Vectorworks in 3D with all the relations and the specification, content and guidance from NBS. Okay, so that wraps up today's webinar. We're going to send 3 links through afterwards, but if you want us to proactively sort of get in touch, organize a more detailed demo, pop something in the chat in the questions now. But we've looked at the early stage specification with the links to the BCIS cost and carbon indicators. So we'll send a link where you can find more information about that particular content add-on, whether you're common arrangement work sections or uniclass for your specifications. You may have seen our monthly newsletter a couple of weeks ago, which talked about how Chorus is available now in 3 plans. We put what we previously called the advanced bundles all together in Chorus Premium. So we're going to send a link out showing the differences. There's been a few sort of questions I've noticed coming to our customer-facing teams, and what is the difference between Chorus, Chorus Pro, Chorus Premium? So if you want to know more about that, again, pop it in the questions, but we'll send a link through as well. But some great functionality in Chorus Premium, detailed revisions, variables, group permissions, practice-wide search, and coming soon, things like tagging, master change, notification. There's a special offer at the moment, 25% discount. So please get in touch if you want to know more about Chorus Premium. And finally, we'll send the link through as well in terms of the 3D model plugins as well. One final thank you again to Vectorworks for providing that great video. It's a guy called Luca at Vectorworks. Thank you, Luca. But pop a message in the chat if you want to know anything about anything we talked about today. Visit the NBS.com. Visit NBS Source to find out the manufacturer content as well. But thanks for your time today. You can drop us an email, info@nbs.com, or go to our website, the NBS.com. Thank you very much, and bye-bye.